The properties of covariance. If x and y are two random variables, then what is covariance is given as Cxy is equal to Rxy minus x bar y bar. This is the formula for covariance. Cxy is equal to Rxy minus x bar y bar. What is Rxy? Rxy is called correlation. Rxy is given as expected value of xy. Correlation is given as expected value of xy. This is the formula for correlation. Okay. Now we see the proof of this. So covariance Cxy is given as expected value of x minus x bar, y minus y bar. Now we just multiply these two terms, x minus x bar and y minus y bar. If you multiply, you get x into y, x minus x into y bar minus x into y bar, x bar into y, minus minus, so it becomes plus x bar into y bar. So we get x bar, y bar here. Now we apply this expectation to each and every term inside this bracket. So that you get expected value of xy minus expected value of x bar y minus expected value of x y bar plus expected value of x bar y bar. Okay. Now we know that what is x bar? X bar is called mean. Okay, it is the mean of x and this value is equal to some constant. Its value is equal to some constant. Okay, and similarly y bar is also some constant and x bar y bar is also some constant. Okay, so from the properties of expectation, we know that expected value of some constant into any variable a into x will be equal to what? So it is equal to a into expected value of x. Okay, since a can be written outside because a is a constant. Here also x bar is constant. So that we can write x bar outside and y bar is also constant. We can write out y bar outside. Okay. So that is why this equation can be written as expected value of xy minus x bar is constant, no? X bar expected value of y and here y bar is constant, y bar expected value of x plus expected value of x bar y bar. And we also discussed that x bar y bar is also constant. So expected value of x bar y bar is equal to what? X bar y bar only, because expectation of constant will be equal to the same constant. Okay, so that is why we will be getting x bar y bar only. And from this equation we know that what is expected value of y? Expected value of y is nothing but y bar, expected value of x is nothing but x bar. Okay, so that is why this equation can be written as expected value of xy is equal to xy minus x bar y bar minus y bar x bar plus x bar y bar. Okay, so from this equation these two terms will get cancelled. These two terms will get cancelled. So we're left with only these two terms. That is expected value of xy minus x bar y bar. And just now we have discussed that what is expected value of xy? Expected value of xy is nothing but correlation. Correlation we denote with as Rxy. So Cxy is equal to Rxy minus x bar y bar. So this is our first property. Now we see the second property. If two random variables x and y are independent, then covariance is 0. So that is Cxy is equal to 0. But the convergence is not true. Okay. So now we consider two random variables x and y. So if you are considering two random variables x and y, so from the correlation properties, see here from the properties of correlation, if the two random variables are independent, that is what is expected value of xy? Expected value of xy is equal to expected value of x into expected value of y. Okay, so expected value of xy will be equal to expected value of x into expected value of y, because x and y are independent. Okay, then the covariance of x and y is given as, you see this from this property, what is cxy? Cxy is equal to rxy minus x bar y bar. So what is rxy? Rxy is expected value of xy minus x bar y bar. Since x and y are independent, expected value of xy is equal to expected value of x into expected value of y minus x bar y bar. Okay. So this can be written as x bar y bar minus x bar y bar. So what is the value will be 0. So if x and y are independent, if x and y are independent, what is their covariance will be equal to 0. Now similarly, if for example, if xy expectation of xy is equal to 0 and expectation of x is 0, then or expectation of y is 0, in that case also we get covariance is equal to 0. So in this case the random variables are not independent, even then we are getting covariance is equal to 0. So whenever you get covariance is equal to 0, you should not assume that the random variables are independent. Okay. So in some cases we get Cxy is equal to 0, even then the random variables are not independent. Okay. So that is why convergence is not true. Okay. If you have independent random variable, what is that covariance? Covariance will be 0. So if covariance is equal to 0, you don't assume that the random variables are independent because convergence is not true here. So this is our second property. Now we'll see the third property for two random variables x and y. So variance of x plus y is equal to variance of x plus variance of y plus 2 covariance of xy. Similarly, variance of x minus y is equal to variance of x plus variance of y minus 2 covariance of xy. Okay. Now we know that if consider two random variables x and y. What is variance of x? Variance of x is given as sigma x square. What is the formula for variance of x? Sigma x square is equal to expected value of x square minus expected value of x whole square. This is the formula for finding the variance of x. Okay. So what is that? Expected value of x square minus expected value of x whole square. Okay. Similarly, variance of x plus y can be written as, see, we just replace x with x plus y. Okay, expected value of x plus y whole square. So in the place of x, we are just replacing x plus y. Okay, so it is expected value of x plus y square minus expected value of x plus y whole square. Okay, this is the formula for variance of x plus y. Okay. Variance of x plus y. Okay. Now we just expand this x plus y whole square. This can be written as x square plus y square plus 2xy. Okay. And similarly, this expectation will be applied to each and every term inside this. So we can write it as expectation of x plus expectation of y whole square. Okay. Now apply this expectation to each and every term inside. So this can be written as expectation of x square plus expectation of y square plus 2 times of expectation of xy minus, we just expand this now. If you expand this, we get expectation of x whole square plus expectation of y whole square plus 2 times of expectation of x and expectation of y. Okay. And if you take this, if you consider this negative sign also, we'll be getting this equation, that is expectation of x square plus expectation of y square plus 2 expectation of xy minus expectation of x whole square expectation of y whole square minus 2 expectation of x expectation of 1. Okay, this is the formula we get. Now we have discussed that what is the variance of x. Variance of x is equal to expectation of x square minus expectation of x whole square. Okay, so that is why expectation of x square, this two terms, this term and this term we are combining. Okay, expectation of x square minus expectation of x whole square. Similarly, expectation of y square minus expectation of y whole square. Okay, and we also combine these two terms, expectation of xy minus expectation of x expectation of y. Okay, so we got these terms. So from this we know that what is this equation. This is the equation for variance of x, and this is the equation for variance of y, and this is the equation for covariance. Okay, so expectation of xy minus expectation of x expectation of y. So this is the equation for covariance. So from this equation we can write it as variance of x plus y is equal to variance of x plus variance of y plus 2 times of cxy. Similarly, variance of x minus y, it is given as expectation of x minus y square minus expectation of x minus y whole square. Okay, this is the formula for variance of x minus y. The same procedure will follow here. Just expand this x minus y whole square, okay, and apply this expectation to each and every term inside, then expand, okay. So if we expand this x minus y whole square, we get x square plus y square minus 2xy, okay. And if you apply expectation to each and every term, we get expectation of x minus expectation of y whole square, okay. Now apply expectation to each and every term here. So this is expectation of x square plus expectation of y square minus 2 expectation of xy minus expand this. If you expand this a minus b whole square form, so we get expectation of x whole square minus expectation of y whole square plus expectation of x into expectation of y. So the same way here also we can combine these two terms, expectation of x square minus expectation of x whole square, that gives us variance of x. Similarly, expectation of y square minus expectation of y whole square, this gives us variance of y, and take minus 2 common, so that we get expectation of xy minus expectation of x expectation of y, that is nothing but covariance, okay. So from that what we got, variance of x minus y is equal to sigma x square plus sigma y square minus 2 cxy, okay. So this is our third property. And the fourth property says that the two random variables x and y, the then this property shows that this inequality is true. What is the inequality? Mod sigma xy will be always less than or equal to sigma x into sigma y. Okay, so this is the inequality, it will satisfy. Okay, so from this we know that x and y are two random variables. We are writing covariance. What is covariance? C is xy is equal to sigma xy is equal to expected value of x minus x bar, y minus y bar. Okay, and from the properties of covariance also we know that cxy is equal to what? Rxy minus x bar y bar. What is Rxy? Rxy is nothing but expected value of xy, okay, minus x bar is expectation of x, and y bar is expectation of y, okay. So cxy can also be written like this, okay. And now here we are considering one inequality. See, the inequality is considered like this: y minus y bar minus k x minus x bar whole square. Since we are taking whole square, then what happens to this value? This value will be always greater than or equal to 0. This value will be always positive. Okay, to obtain the positive value, we have to assume this condition. So what is the condition we have to assume? See, y minus y bar minus k x minus x bar whole square will be always greater than or equal to 0, because we have taken square, okay. So that is why the negative value will also become positive, so it is always greater than or equal to 0. Now if you take any value whose value greater than or equal to 0, expectation of that value will also be positive only. So expectation of x minus y minus y bar minus k into x minus x bar whole square is always greater than or equal to 0. Now we just expand this. See here, it is a minus b whole square form. We just expand this. We can write it as y minus y bar square plus k square x minus x bar square minus 2k y minus y bar x minus x bar greater than or equal to 0. Okay, so this, now we apply this expectation to each and every term inside this bracket, so that we get expectation of y minus y bar square plus k square into expected value of x minus x bar square minus 2k expected value of y minus y bar x minus x bar. And we know that what is this value? Expected value of y minus y bar square is nothing but variance of y, yes or no? And k square, what is this value? It is the variance of x, okay? So plus k square, variance of x minus 2k, what is this? This is nothing but covariance. Covariance is what? Sigma xy. So it is always greater than or equal to 0. Now we divide this equation by sigma xy square, x square, okay? So if you divide, then also you get positive only. So if you divide it, what you get? Sigma y square by sigma x square plus k square sigma x square by sigma x square minus 2k sigma xy by sigma x square greater than or equal to 0. Okay. Now if you compare this here, so what is that we have here? You observe, we get sigma xy by sigma x square and k square, we have no k square. So k square is already there, and we have to have sigma xy by sigma x square whole square. That is why then only we can write. Consider by considering these two equations, these two terms, we can write it as a minus b form, a minus b whole square form. Okay, so here we got k square sigma y square by sigma x square minus 2k sigma xy divided by sigma x square. Okay, what we do here, we just add sigma xy divided by sigma x square whole square term, so that we want to write it in the form a minus b square form. Okay, so 2ab, no, a is already there, k square is there, b square we want to get, b square sigma xy by sigma x whole square, sigma x square whole square, we have to add and subtract. That is why this term is added and subtracted, so that the effect will not be, there is no change in this equation. Okay, now you compare these three terms. If you compare these three terms, it is in the form a square plus b square minus 2ab form. Okay, so that is why we can write it as k minus sigma xy divided by sigma x square whole square. And these two terms we are writing again separately. It is plus sigma y square by sigma x square minus sigma xy square by sigma x power 4 is greater than or equal to 0. Since you are squaring it, no, whenever you square, the negative number will also become positive. So since it is squared here, this term is always positive. You don't need to consider this term. This is always positive. Okay, now we have to consider this term.